In your notebook, write today's date, 8.2, apply exponent properties involving quotients. Quotient is the answer you get after the division is done. So you will be able to apply the exponent properties involving quotients. Copy these notes down. Just like you had the products, the exponent properties involving products, you have certain rules that involves quotient. So the quotient of the powers, you subtract the exponent. That is rule number 1. The second rule is this: the power of the quotient, find the power of the numerator, find the power of the denominator, expand, simplify, and then divide. So the question is asking you to simplify the expression, write your answer using exponents. So let's figure out question number 6. So you get -6, the whole entire thing gets a power of 8. So if I were to expand the numerator, it's going to look like -6, 8 times. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The denominator, if I expand, it needs to appear 5 times. So I'm doing -6, 2, 3, 4, 5. So the exponent tells me how many times I need to repeat that number. So now if I look at the numerator and the denominator, I can cancel these two. I can cancel these two. Cancel these, cancel this numerator and this denominator, cancel this numerator and this denominator. So now all I'm left with is just -6 times -6 times -6. So which basically means this is all I am left with after all the cancellation is done. So I have -6 repeats 1, 2, 3. It repeats 3 times. So if you apply the exponent properties involving quotients, all I have to do is I have a numerator and a denominator. The base is still the same thing. -6 is the same on the top and on the bottom. So I'm just going to write it once. And now watch what I'm going to do using the highlighter. 8, 5. 8 minus 5 is going to give me a 3, which is the same answer I got by expanding. So that is the rule. Now copy question number 16. So I get 1 over 9 to the power of 5 times 9 to the power of 11. I'm just going to write a 1 on the bottom. If there is a denominator missing, always make sure that you write a 1. So 1 times 9 to the power of 11 is going to be 9 to the power of 11. 9 to the power of 5 times 1 is just going to be 9 to the power of 5. So now all I have to do is, if I apply the exponent properties involving quotients, which is this rule, the quotient of the powers, you just got to subtract the exponents. You subtract the exponents provided the base is still the same. The base is a 9 on the numerator. The base is the same on the denominator. Keep the 9 exactly the same. And the only things you're going to subtract will be just 11 and the 5. 11 minus 5 is going to give you 6, and that is it. Copy question number 26. So you have -1 over x gets the whole entire to the power of 5. Now, if you have the power outside the parenthesis, the 5 goes for the sign, the 5 goes for the number, the 5 goes for the letter. It goes for every single one of the terms. So I'm going to write negative gets the power of 5, 1 gets the power of 5, and the denominator x also gets the power of 5. Watch this again. Negative gets the power of 5, 1 gets the power of 5, denominator x gets the power of 5. So if I were to expand this, it's going to look like negative, 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 and negative. And 1 to the power of 5 is nothing but 1. 1 times 1 times 1 times 1 times 1 is going to be 1. And x to the power of 5. Now these two negatives becomes a positive. These two negative become positive. So these become positive. I'm stuck with a negative. So it's going to be -1 over x to the power of 5. And that will be the answer for question number 26. Pause the video, rewind the video, and rewatch it again to understand this. Copy question number 36. This one, please do not do it in your head. There are multiple steps involved, and you got to be careful on the rules for the exponents, and you have negatives to deal with also. So if you look at the first one, the 2 goes with the negative, the 2 goes with the 5, the 2 goes with the x. So if you expand that, it's going to look like negative gets a 2, 5 gets a 2. Anytime you are expanding and applying, make sure that you stick it inside a parenthesis, and the denominator x gets a 2. So that'll be the first step. Rewind and rewatch, and this will be a little bit more clear. Times, now 2, if I use the blue, 2 goes for the 2, 2 goes for the x, 2 goes for the y. It goes for each one of them. So I'm going to write 2 gets a 2, x4 gets the 2. You have to write it within the parenthesis. The denominator y3 gets a 2. So once you're done applying the powers, now you need to expand. Negative to the power of 2. So negative to the power of 2 is nothing but negative times negative. Negative times negative becomes positive. So this will become a positive. 5 to the power of 2 is nothing but 25. 5 squared is 5 times 5, which is 25. X squared stays the same. So the whole entire thing changes to this. Now if you look on the right side, 2 to the power of 2. 2 to the power of 2 is 4. 2 squared is 2 times 2, which is 4. x4 gets the power of 2. So that becomes x to the power of 8. This will be the power of the power, which means you multiply the exponents. Now let's focus on the denominator. Y gets the power of 6. Power of the power. So you multiply. 3 times 2 is 6. So now comes the last step. You need to simplify. 25 times 4 gives you 100. You multiply the numbers if they are on the same level. So you get x to the power of 8, denominator x squared, y6. So now if you look at 100, there is nothing else to do. The denominator y6 I cannot combine with anything, but I can combine my x's. Watch what I'm doing. So I have x squared, I have x8. So x8 is on the numerator, x squared is on the denominator. So the power of the quotients means you subtract the exponents. If they are on the same level, you add the exponents. If they are on the two different levels, you subtract the exponents. So what I'm going to do is, I'm going to take my x to the power of 8, x to the power of 2, and I'm going to end up in getting x to the power of 6. 8 minus 2 is what you're subtracting. So this will change to x to the power of 6. And this will be the final simplified version.